So imagine asking your computer for the weather. And instead of just giving you a link to a forecast, it actually notices it's going to rain.
Right.
And then it checks your calendar, sees you have like an outdoor lunch scheduled, and automatically drafts an email to your team to move the reservation inside.
Yeah, which is incredible.
Right. That is the leap from a standard AI to an agentic AI.
Yeah.
I mean, the difference between a glorified encyclopedia and, well, a digital employee.
A really proactive employee, yeah.
Exactly.
Right? Yeah.
But if you try to figure out how to build one of these things right now, you aren't handed some, simple instruction manual. You just get hit with this mountain of jargon.
Oh, absolutely.
Frameworks, runtimes, models, wrappers. It feels less like learning a new tool and more like, I don't know, trying to build a spaceship from scratch in your garage.
It is an incredibly intimidating landscape for anyone just standing on the outside looking in because, we naturally prefer things to be visible and neatly categorized.
Right, like a clear user interface.
Exactly. But modern AI architecture operates almost entirely behind the scenes, which just makes the educational waters extremely muddy. And if you approach it by, say, just trying to memorize code snippets.
Which a lot of people do.
They do, but you are setting yourself up to fail if you do that.
Which is actually the perfect jumping off point for our mission today.
Mm-hmm.
We are taking on a very specific challenge alongside you listening.
Yeah.
Understanding agentic AI from absolutely zero.
Yes.
And we are using a really fascinating source text to guide us. It's called Foundations of Agentic AI, Building from Zero. And what stands out about this material is, well, its core philosophy.
Yeah, the philosophy is key here.
Right. It argues that this isn't about memorizing lines of Python so you can just copy and paste them. It's about fundamentally rewiring your brain to learn how an AI engineer actually thinks.
And that distinction changes everything. I mean, truly, because in the AI world, a framework might update and change its entire syntax on, like, a random Tuesday.
Oh, yeah, totally.
So if your knowledge is just memorized code, you literally become obsolete overnight. But if you grasp the underlying logic,
The why behind it.
exactly, the why behind each invisible component, then you can adapt to any new tool that hits the market.
So I'm looking at this text, and my immediate worry, and maybe you listening are thinking this too, is this going to require a master's degree in machine learning?
Right.
I mean, the source mentions someone who knows basic programming but has zero idea what agentic AI is. Can someone actually grasp this architecture without a background in natural language processing? Or without knowing what on earth LangChain or Ollama even are?
Well, the source is incredibly adamant about this. You do not need machine learning background.
Oh, really? None at all?
None. You don't need to understand, like, the complex math of neural networks to build with them. The text uses this brilliant analogy to ground the whole concept.
Okay, let's hear it.
So imagine we are building a house.
Okay.
You don't start out by framing the second-story windows, right? Or deciding what color the roof shingles will be.
Right, you pour the concrete.
Exactly. You establish a foundation that can actually support the complex structures later. If you try to jump straight into building complex AI agents without understanding the invisible boxes that make them function, your digital house is just going to collapse.
Well, we are definitely pouring the concrete today. But before we get our hands dirty with the how, I think we need to nail down the what's.
Yeah, that makes sense.
Like, why is the entire tech industry suddenly obsessed with the term AI agents instead of just talking about large language models, or LLMs, like we were just a year ago? What is the actual functional difference?
So to understand that pivot, we really have to look at a fundamental limitation of traditional LLMs. And the source text uses a fantastic thought exercise to illustrate this. Let's try it right now.
Okay, I'm ready.
If I ask you right now, what is 20 multiplied by 50?
I could just do that in my head. That's 1,000.
Right. You didn't leave the room. You didn't open your laptop. You calculated that mentally using the pre-existing knowledge stored in your brain. And a traditional large language model operates the exact same way.
Oh, I see.
Yeah, it relies entirely on its internal, pre-trained knowledge base. It receives a prompt, it thinks, and it generates text based purely on what it learned during training.
So it's essentially a closed-loop system.
Exactly. Now, suppose I ask you, what is today's exact weather temperature in Hyderabad, India?
Yeah, I have absolutely no idea. I'd have to, like, pull out my phone, open a browser, and search for it.
Right. Notice the shift in your cognitive process there. You hit a hard limit to your internal knowledge.
Yeah, my brain couldn't do it.
But more importantly, you recognized that limit, and you formulated a plan to use an external tool to bridge the gap.
Wow. Okay.
An AI agent introduces that exact moment of self-reflection into the software.
I really want to trace the logical flow here because the text lays it out so cleanly. So a traditional LLM flow is linear, right?
Yeah.
Question comes in, the model thinks, the model answers, done.
Right, very straightforward.
But an AI agent flow adds this crucial detour. A question comes in, the model thinks, and then it pauses to ask itself, wait, do I need a tool to answer this?
Exactly.
And if yes, it pauses its response, reaches out to, say, a calculator or a search engine, pulls that information back into its context, and then generates the final answer.
Yeah, it shifts the AI from being just a conversationalist to being an active problem solver.
Taking that further, it feels like a traditional LLM is basically a student stuck in a strictly closed book exam.
That's a great way to put it.
Right, like they can only rely on rote memorization, and if they didn't study that specific fact, they just, hallucinate a guess or fail.
Which we see all the time with standard chatbots.
Exactly. But an AI agent is a student taking an open book test. They don't need to memorize the entire encyclopedia. They just need the intelligence to know when to open the encyclopedia or when to grab a calculator.
That analogy perfectly captures the simplest, most vital beginner definition you can take away from this text. An AI agent is simply an LLM that knows how to use tools.
I love that. So simple.
Yeah, it is not some mystical new form of consciousness. It is literally just a language model equipped with digital hands to interact with the outside world.
Okay, so an LLM that knows how to use tools. But, brains and calculators don't actually talk to each other, right?
No, they don't.
So if I ask my open book student to do complex math, how does the system actually route that request? Like, what does the actual architecture look like? Because we obviously need to connect the brain to those digital hands.
Well, let's deconstruct the actual tech stack then. The source sets up a really practical scenario to trace this architecture, and it refers to it as the Iron Man suit.
Oh, that's fun. Okay.
Yeah. So imagine you are interacting with an AI application we've built, and you type in, what is 15 multiplied by 14 plus 10?
Okay.
We have to trace how that question travels through all the invisible components to actually get an answer back to your screen.
Let's start with the brain then. The text uses a specific model for this foundation, right? Llama 3.2.
Right. Llama 3.2 is the model doing the heavy lifting here. To use the text's metaphor, Llama is the actual genius locked inside a room.
The genius in the room. Got it.
This is the core intelligence. This is the entity that parses your English, understands the logic of your question, and does the actual reasoning. All the cognitive power in your application lives in this one isolated room.
But the genius is locked in.
Yes.
So if my application is written in Python Dash, which is, the standard programming language here, and Python wants to ask the genius a question, it can't just yell through the drywall, right?
No, the door is firmly shut. Llama 3.2 on its own is essentially just a massive gigabyte-heavy file of weights and parameters sitting on a hard drive.
So it's basically asleep.
It is completely inert. It can't listen for inputs or broadcast outputs on its own. It needs a specific hosting environment to bring it to life.
I'm guessing this is where some of that intimidating jargon comes in. So who actually opens the door?
That is the role of Ollama.
Ollama. Okay.
Yeah, Ollama is the runtime. Think of it as the person holding the door open so you can finally talk to the genius. Without Ollama serving the model, the file remains inert, and your Python script gets zero response.
That makes total sense.
Ollama takes that static file and spins it up into an active running service that can actually receive data and send data back.
Okay, so Llama's the genius, Ollama's the door opener. Where does Python actually fit into this physical space? Because the source has a great robot analogy here.
Oh, yes, the robot analogy.
Yeah, it says, imagine you buy a brilliant state-of-the-art robot. You unbox it. But it doesn't just spontaneously turn itself on and start making you breakfast.
Right, sadly.
Someone has to actually press the power button, issue the command, and observe the result.
Exactly. Python is the person holding the remote control. It is the connective tissue of the whole operation.
So it's running the show.
Right. Your Python script contains the instructions that basically say, start the application, take the user's math problem, send that text to the door opener, Ollama, wait for the genius, Llama, to process it.
And then give it back to me.
Exactly. Take the resulting answer and print it out on the user's screen. Python is managing the sequence of events.
So Python is basically me poking the genius with a stick, saying, hey, do something.
Pretty much.
But wait, if we're building an agent like an open book test, and we want this genius to use a calculator for our math problem, Python alone coordinating with Llama seems like it would get incredibly messy.
Oh, it would be an absolute coding nightmare.
Because now the genius isn't just answering directly, right?
Right. Now the genius is returning a message saying, hold on, I need a calculator. If you were just using Python, you would have to write custom code to constantly monitor the genius's output.
Ugh, sounds tedious.
It is. Every time it asks for a tool, you would have to pause the entire system, go find a calculator script, execute the math, take the result, walk back to the door, hand it to the genius and say, here's the math, now finish your original thought.
And I'd have to write that custom if-rending logic for every single tool, wouldn't I? The calculator, the internet search, the calendar. I mean, that sounds impossible to maintain.
Which is exactly why the industry relies on a dedicated manager. And this is where the source brings in the Iron Man suit analogy.
Right. Tony Stark's armor.
Think about it.
Yeah.
You have the human brain inside, but you also have the visual heads-up display, the repulsor blasters, the internet connection, the targeting system.
All these separate systems.
Yeah, and trying to manually wire all those separate components together so they communicate seamlessly in like a fraction of a second would be impossible for one person to manage.
You need Jarvis.
Yeah.
You literally need a centralized operating system specialized in coordinating all those moving parts.
Exactly. And in our tech stack, LangChain is Jarvis.
Okay, LangChain.
LangChain is the framework specifically designed to manage AI workflows. When the Llama genius says, I need a calculator, LangChain intercepts that request automatically.
So it just handles it.
It knows exactly where the calculator tool is, it routes the data, it gets the numerical answer, and it feeds it back into the genius's context window. It handles all that chaotic traffic without you having to write hundreds of lines of custom routing logic in Python.
I want to push back on this for a second, though, just to establish firm boundaries for you listening.
Sure.
If LangChain is this incredibly powerful manager, coordinating the calculator, the internet access, and the entire flow of this Iron Man suit, does LangChain itself actually possess intelligence? Does the manager think?
A definitive no.
Okay.
LangChain does not think. It has absolutely zero intelligence or reasoning capability. It is purely a routing system.
Good to know.
It's basically a set of sophisticated, pre-written instructions on how to move data from point A to point B. Llama thinks. LangChain manages.
That's a great distinction.
Imagine a highly organized project manager with a clipboard and a brilliant subject matter expert. The project manager organizes the schedule, books the meeting rooms, delivers the mail, but they rely entirely on the expert to actually solve the complex problems.
That distinction right there, that is the exact mindset shift the source talks about. Knowing the difference between the manager and the thinker is what separates someone who just blindly copies code from a true AI engineer.
Absolutely. Because when you are learning from zero, the biggest trap is conflating the infrastructure with the intelligence. You start believing the tools are doing the thinking.
The source actually has a specific Think Like an Engineer section that tackles this head on. And I want to run through these beginner traps as a little mini quiz for you listeners.
Oh, this is a great exercise.
Take a second and mentally answer these as we go, based on the architecture we just mapped out. Ready? First one, is Python the AI?
No. Python is just the programming language. It is the controller, the nervous system that sends the electrical signals.
Okay. Second one, is LangChain the AI?
Still no. LangChain is the framework. It is the project manager, the Jarvis, coordinating the Iron Man suit. It routes the information perfectly, but it has an empty head.
Right. Third one, and the naming convention here always trips people up, is Ollama the AI?
No. Ollama is the runtime. It is just the entity opening the door so you can communicate with the room. It serves the model, but it contains no reasoning capabilities itself.
So bringing it all home, where does the true source of intelligence actually live in this entire stack?
In the architecture we just built, the singular source of intelligence comes exclusively from the model. Llama 3.2.
The genius in the room.
Exactly. That is the only component doing any actual cognitive work. Python, LangChain, Ollama, they're just the necessary scaffolding built around that brain so it can successfully interact with your world.
Okay, so we have our foundation poured. We know exactly what the concrete is made of. But the lingering question is, well, if we understand these building blocks, what does this foundation actually allow us to construct?
Well, the source outlines a very clear roadmap showing how your capabilities scale as an engineer once you master these basics. You don't jump straight into building a fully autonomous digital employee.
Right, you have to work up to it.
You stack these concepts.
I really want to dig into that roadmap. How do we evolve from this basic setup?
You start with the first LLM, This is just getting Python to talk to Llama through Ollama.
Okay, the baseline.
Yeah, establishing that baseline closed book test. But once you have that running smoothly, you upgrade to a calculator agent.
And that introduces LangChain, right?
Yeah.
We give the genius a single tool to see if the manager can route it properly.
Correct. But the real leap, the really fascinating part, happens at the next stage, the multi-turn chatbot.
Oh, interesting. Why is that a leap?
Because standard LLM interactions are inherently amnesiac.
Amnesiac.
Yeah. If you ask a question, get an answer, and then ask a follow-up, the model has already completely forgotten your first question.
Wow, I think a lot of people just assume the AI naturally remembers the conversation, like a human would. How does it actually hold a multi-turn conversation if it has amnesia?
You basically have to force it to remember.
How so?
This requires engineering a system where your Python script or your LangChain manager takes the entire history of the chat, every question you asked, every answer it gave, and secretly appends it to your newest prompt.
Oh, wow.
Yeah, you are constantly refeeding the AI its own past, so it has the context to answer the present.
But wait, eventually that chat history is going to get massive.
Yeah.
I mean, you can't feed a 50-page transcript into the prompt every single time you just say hello. That seems like it would crash the system or just cost a fortune in compute power.
Which naturally necessitates the next evolution on the roadmap, the memory agent.
Oh.
A memory agent doesn't just blindly paste the whole transcript. It uses tools to read and write to an external database, usually a vector database.
So it's like a filing cabinet.
Exactly. When you ask a question, the agent searches that database for only the relevant memories, pulls just those specific facts, and uses them.
That's so much more efficient.
Right. It allows the agent to have persistent context about your preferences across weeks or even months of interactions without overloading its immediate memory.
Okay, so we go from a basic brain to giving it a calculator, to giving it a short-term memory loop, to giving it a long-term database. What is the final destination of this foundational volume?
The culmination is reaching the level of a LangGraph agent.
LangGraph. That sounds a bit heavier than standard LangChain. How does that change the game?
LangGraph introduces complex cyclic workflows. Up until now, our flow has been relatively linear. Question comes in, agent gets a tool, agent answers.
Right, straight line.
But real-world problem solving isn't linear, is it? It's a loop of trial and error.
Can you give me an example of what that cyclic loop actually looks like in practice?
Sure. Imagine asking an agent to write a complex piece of software. A standard agent writes the code and hands it to you. If it's broken, you have to figure it out and tell it.
Which is super frustrating.
Yeah. But a LangGraph agent writes the code and then uses a tool to actually run the code itself.
Wait, it tests its own work.
Exactly. And if it encounters an error, the agent reads its own error message, reflects on what went wrong, routes back to beginning, rewrites the code, and tests it again.
That is mind-blowing.
It cycles through that loop autonomously until the code works perfectly, and only then does it present the final result to you.
Yeah.
It is the true realization of an autonomous agentic AI.
That completely demystifies the magic for me. To recap the massive aha moments we've hit today for you listening, we've moved past the intimidation.
We have.
An AI application is really just a highly specialized team of distinct tools. You have your controller issuing commands, which is Python. You have your door opener allowing access, which is Ollama. You have your meticulous project manager routing the workflow, which is LangChain. And sitting right in the center, you have the genius doing the actual reasoning, Llama 3.2.
It's all about the pieces fitting together.
Yeah, you are no longer just marveling at the software, you are understanding the physics of the software.
And when you break it down into those distinct roles, the architecture stops being a black box. You stop being afraid of the components and start seeing how they click together to build incredible things.
Absolutely.
We talked about how an agentic AI is powerful because it realizes it needs tools and how a framework manages those tools. But I want to leave you with this.
Okay, let's hear it.
Think about the endpoint of that roadmap. The LangGraph agent capable of cyclic reflection.
The one that checks its own work.
Exactly. If we give the genius in the room access to a project manager that can utilize virtually any digital tool search engines, databases, code execution environments, email servers, and we allow it to autonomously loop, reflect, and plan its own workflows. At what point does the AI stop merely answering the prompts we give it and start designing its own systems to solve problems we didn't even know we had?
Yeah.
That is the frontier this foundation prepares you for.
Keep that Iron Man suit analogy in your back pocket as you continue to explore this new world of AI. It will serve you incredibly well. We'll see you on the next deep dive.